Good morning, everybody. Welcome to Respoke 101, or at least that's what they tell me this session is, and if it's not, sorry, but it's going to be pretty awesome. So my name is Dave Lee. I am currently lead DevOps for Respoke. I have been a number of things over the years, including software developer for Respoke, software developer for Asterisk, and a lot more than I care to recount now. So this is going to be a fairly introductory session into Respoke. I'm going to show you how you can use Respoke in your web applications. We do have some mobile SDKs for Android and iOS, but I'm not going to get as much into that. But if you're interested in that, you can come talk to me afterwards and we can give you some more information on those. Let's see, some quick overviews, how to get started with Respoke. I'm going to walk through the major APIs that we have with Respoke, the biggest things you're going to use for us. Then we're actually going to get into a lot of code. I am a software developer at heart, and I would be really dismayed if I ever did any presentation that had insignificant amounts of code. So we'll be walking through a fairly simple example of using Respoke. And then I'm going to go through some of the gotchas and debugging and things that tend to trip people up whenever they're building Respoke and actually WebRTC apps in general. So because usually the problem isn't with Respoke, it's with browsers, it's with network connectivity, it's with any number of things, trying to get these things to work. I did hurriedly finish my presentation this morning, and I've posted this in the code I'm going to have to GitHub. LeeDM777 is my GitHub handle, and you can find Respoke 101 there if you want to get the code. I have also learned to never ever trust the networking at a conference, so I'm running everything locally, but ignore any like testing.digium labs URLs you see in browsers and things like that. I'll tell you what the real things are. So, but you should be able to go there. You can see my slides up there. You can see the code I'm going to be working with. Let's see, Respoke. What is Respoke? Respoke is, at its core, a web communications platform. We have a number of services that we provide that enable messaging. It enables voice and video services for both web applications and mobile applications, both iOS and Android. We have a number of features. Here's the big feature list. We'll be going through these one at a time. We do have actually a couple of early access features. If you're interested in those, you can send an email to support@respoke.io and just say, hey, I'm interested in such and such, and or even if you have feature requests for things that you don't see on this list, you can let us know what you're interested in, and we'll be happy to either turn on the early access feature or talk to you about building something new. Let's see, so getting started. There are a number of links that we have for getting into Respoke. Your main entryway is obviously going to be our website, www.respoke.io. We also have a fairly comprehensive documentation site, docs.respoke.io, and our docs are open source. I should have put the GitHub URL up here, but if you find errors in the documentation, you can create an issue on the GitHub site, or if you want to get involved, you can submit a pull request. We happily accept pull requests on our documentation. So, and then we also have our management portal, portal.respoke.io. You can usually get to anything from the main www site. Actually, I wanted to, go away, and so here, the main website, and you can also enter the portal, sign up and sign on through our documentation site. As I said, we've got documentation for all of our client-side libraries. We have a number of server-side libraries. We have documentations for that. And then we have our dashboard for the main portal. Let's see, going back. So the other thing, I'm going to be using primarily JavaScript today because that is the language of the web, and even when I talk about server-side, I'm going to be using Node.js, so that'll be JavaScript as well. There are a number of patterns that we use with the Respoke.js APIs. We do our best to be flexible So whatever coding style or development methods that you have, we should be able to adapt, and you should be able to use our APIs pretty straightforwardly. In JavaScript, obviously, or in JavaScript, for people who have used it for any length of time, you know that it's single-threaded and you have to deal with asynchronous callback-based programming. And there's usually two ways, and today there's two main ways of dealing with that. The first is callback functions, and the second is promises. Respoke.js API supports both. Most of our every one of our asynchronous APIs will, you can either pass in an onSuccess or onError callback function. And whenever the asynchronous method completes, it will call back on that function so that you can continue on with whatever processing that you need to do. If you're really hip on promises or ES 2015 or the newer JavaScript standards, you can use that. If you do not pass in these handlers, then instead the method will return a promise. And if you're familiar with promises, you can continue to use that. If you're not familiar with them, you can just continue to use callback-based programming as we've always done. We also do have an event emitter in Respoke.js, and we use that extensively. For the most part, whenever you create something or initiate an action, if there are events associated with that, you can pass the event emitters into that creation function. So, you know, you can say on some event or whatever the event is. Those are listed extensively in the documentation. You know, alternatively, the object itself is an event emitter, and so you can call .listen or I forget what the other methods are. Oh, well, you can call .listen to subscribe to those events at a later point, and there's an unsubscribe method, and those are also documented in the API docs. We do support many, many different styles of front-end development. For the purposes of the session here, I'm just going to stick with one for the most part. I'm not going to tell you the 50 different ways we have for doing things. But and also, I'm going to show abbreviated code examples. I'm not going to show you all the parameters that we take for all of our methods. Those are fully explained on our documentation site. You can, we have extensive API docs that you can find on the doc site as well. If you want to find more information and see all the gritty details of these API calls, you can find that there. So, let's see. Getting started. With Respoke, the central concept we have in Respoke is what we call an application. You will create these applications via the Respoke portal. The application itself is identified by an application ID. This is just a little UUID string that you're going to use within your server-side applications to identify which app you're connecting to. We also, as a security mechanism, we have what's called an app secret. This is a shared secret between Respoke and your application that you will use to authenticate whenever you establish your server connection to the Respoke APIs. I guess sort of like the biggest constraint that we have is that application endpoints can only communicate with other endpoints within the same application. And so if you have multiple Respoke applications and you need them to do some cross-app communication, you can build that yourself. All of our clients support multiple connections, and so you can have one connection to application A, one connection to application B, and sort of bridge those together yourself if you really need that. For the most part, that has never been a problem. You just sort of have your application and you connect to Respoke and you can communicate with everything else within your app. I did want to sort of show this, so I will, so this is the Respoke portal. This is what it's going to look like when you come here. You can see on the app screen, fairly straightforward. Click this to create a new app. Give it a name, optionally a description for it. And here we have an application. You can see the app ID for the application I just created is this, this UUID string. The app secret is here as well. If you ever get in a situation where you feel that your app secret has been compromised, or maybe you just, as a good security practice, you rotate these, you can click Reset Secret, and it will generate a new one for you and invalidate the old one. Let's see, so that's it's really straightforward to create new applications. We allow you to create as many applications as you need. Usually you'll have separate applications that you're going to use for development versus what you use for production so that they don't interfere with one another. Let's see. Moving on, authentication. So authentication is interesting in the fact that we are a third-party service, but you also have your own authentication or your own way of identifying your customers. So we have two ways of authenticating with Respoke. The first is what we call dev mode. This is the simplest thing to do. It's client only. You enable dev mode at the application level. And it's actually a non-authentication process. All you need is the application ID in order to connect to your Respoke application when it's in dev mode. The permissions for these default to completely permissive. Anything that connects can do basically anything. We do restrict some of our paid features in dev mode just because it's insecure. I mean, that's kind of the point. This is really helpful for playing around with Respoke, getting started. If you have a JS bin or things like that where you just want to fiddle around with Respoke and try some things out just purely client side without having to worry about the step of setting up a server. You would never ever use dev mode in a production application because anyone who gets your application ID, which they will have to get your application ID in order to connect, then they will be able to do anything that they want with your Respoke application. And that is something that you're not going to want, we're not going to want, that sort of thing. So for secure authentication, we have a mechanism known as brokered authentication. This is required whenever you disable dev mode on your Respoke app. It changes the permissions so that they default to being restrictive instead of permissive, and you have to have an authentication server. You have to have your own server to broker the auth, as it were, in order to perform this securely. This is sort of a diagram sort of explaining the process here and sort of the why. It's like, why do we need to have this server? Why do we need to have brokered authentication? Well, to start off with, the client is very light. You can't even see it. Well, you already have an established relationship with the client browser. They have logged into your site, or you have whatever tracking cookies that you have. You know who this client is. You're the one who has established identity of the client already. At some point when you want to use the Respoke services within your application, the client will request a token from your server. This is where you perform your own authentication checks. You can say, okay, is this client who they say they are? What sort of connection do they need? Which permissions do they need? You perform the authentication authorization in your application, and you decide how to request, and then your server requests from the Respoke API servers a token. And you say, here's the endpoint identifier for the token that I need, here's the permissions for that token that I need, and Respoke will respond with a token. As with everything else you've seen, it's just a UUID. You pass that back to the client, and along with whatever other information your application needs in order to use Respoke. At that point, the client will connect directly to the Respoke services using the token that you've given to them. This allows you to be in the process of authentication. This allows you to be in control of who accesses your Respoke application, what permissions do they have, and so on. So an important concept is when you request that token, you supply an endpoint identifier. This is sort of identifies the logical entity that's connecting. When you have a specific connection to your Respoke, that connection is assigned a unique connection ID. We'll sort of demonstrate that here in a minute. Here's sort of an example of how this is typically used. You've got a number of devices that have Respoke connections. You've got Chad over here who is really old school. He has a desktop machine, with a webcam sort of mounted on top of his monitor. He has a single connection. He doesn't do a lot of other things, and that's what he has. So his endpoint ID is going to be Chad. That is the logical identifier that you assign from your application to say, okay, who is this who's connecting? The connection ID is this UUID gibberish thing that identifies, okay, this is Chad's connection. Dave over here is a little more mobile. He's got a couple of devices. He's got his phone. He's got his laptop. So both of those share the same endpoint ID of Dave, but they have individual connection IDs. The reason why that's important is that you can send a message to an endpoint ID without specifying the connection ID, and it will be delivered to all the endpoints that share that endpoint ID. So Jeff is really high tech with lots of devices. If I were to send a message just to the endpoint ID of Jeff, then it will be delivered to all 3 of those devices. If within the scope of your application, you need to address messages to a specific device or a specific connection, then you can specify both the endpoint ID and the connection ID in terms of where you want to send your message, and it will be delivered to just that device. Sorry, I tend to go quickly. Is that clear as mud for everyone? In terms of sending messages, it's a really straightforward. Once you have your client connection to the Respoke APIs, send a message. You specify the endpoint ID. You can optionally specify the connection ID, and then you specify the message that you want to send.
When you said endpoint ID, you mean the user, not the device?
Yes, yes. So the endpoint ID is typically what you'd use to specify the user that you're trying to connect to. Because the Yes, yeah. The connection ID is really about the device you're trying to reach. You know, if you know, okay, I need to reach his mobile phone, then from your application, you would have to figure out, okay, which of his connection IDs is the mobile connection. You know, and you can usually track that pretty well from the application.
I have a question.
Oh, yeah.
Is there a constraint on the number of GUIDs for everyone?
No, we do constrain the number of connections you can have for your application in terms of what paid tier you're at with Respoke. But other than that, no. Any other questions? All right. The next topic is group messaging. Within Respoke, you can create groups, and groups are created ad hoc. An individual connection may join or leave a group. This is an important concept. It is the connection that joins the group, not the endpoint. So if you have 2 devices with the same endpoint ID, if one of them joins a group, it's not necessarily true that the other one is also a member of that group and would receive the same messages. So if you want, you know, depending upon your application, if you want a consistent group experience, then all of your connections will need to register with or subscribe to the same groups. Any message that is sent to the group will be then forwarded on to all of the members of that group. We also have a permission structure where you can fine-tune sort of the members of the group and see who can send messages, who can receive messages, who can see the members of the group, and associated with the membership permission is also who can see the join and leave events for when other members join and leave that same group. Actually, it's worthwhile to sort of show that real quick. So on the permissions, whenever you create a new application, by default development mode is enabled. You would turn this off in order to configure the permissions. These are called roles. I've created a new role. Here, we'll just sort of see here. So for a group permission, you can define whether this role can create or destroy groups, whether it can get the subscribers that are the members of that group, whether it can publish new events or new messages to the group, whether it can subscribe and receive messages from the group, or whether it can unsubscribe from the group. Let's see. So let's see. The group API is also fairly straightforward. Client.join will join a messaging group. The only thing you need to do is specify an ID. That ID is just a user-defined string. It's whatever you want it to be from the scope of your application as far as what identifies that group. That will asynchronously return a group object. Once you have that group object, it's just send a message, and you specify the message that you want to send to the group, and that message will be delivered to all of the other members of that group who have the subscribe permission. Let's see, voice and video calling. These are also fairly straightforward. Start audio call and start video call are your main entry points into starting voice and video calls. There's other parameters in here, especially for video calls, in terms of how you handle your media elements, how you get the video element that you want to display on the web page. But whenever you start an audio or video call, you specify the endpoint ID of the user you're trying to reach, it will send, they will get an event on their side. I forgot to put the event in. They will receive an event on their side that there's an incoming call. At that point, your application can do what you need to. You can pop up a dialog to the user, or if you have a auto answer, you can go ahead and automatically answer from within your application. It's your client application. You can decide what to do with that at that point when you receive the event that a new call is coming in. Another thing that's going to be most interesting for you guys is that we do have Asterisk Integration. We have a channel driver called Respoke that's up on GitHub and is open source. Contributions welcome if you want to help us out with that. Respoke/Respoke. When an Asterisk endpoint is connected with Respoke, it behaves basically just like a web endpoint. You would basically start audio to the Asterisk endpoint just as you would any other web endpoint. Similarly, when your dial commands would route calls to your Respoke endpoint, they will get routed to the endpoint ID that you're specifying. So, all right. You guys ready for some code? Do you think that might, or is it too early in the morning for code? In terms of, what I've done, just in terms of keeping the demonstration simple, is I've also made the font way too small for everyone to see. Yeah. Oh, that's much better. Okay, so this is a fairly straightforward server application. I do have the code here for doing brokered authentication, because I do think that's really important, and that's going to be important early on in your development cycle in terms of building your Respoke application. So this is the server-side code for this little sample application. Let's see. This is an Express application. If you're not familiar with Express, don't worry so much about this. I've added a single route /token. It will create a session. One of the things that I've done is, instead of having any configuration, I randomly generate a name, a human name, and associate it with that with that endpoint, with that web session. And so you'll kind of see these names throughout. It's random. We'll see what we come up with, so it'll be fun. This application is just generating a name and allowing them to connect. Once again, within your application, this is the point where you would have your application logic to authenticate the user and authorize them. Who are they? What do they need to do? What sort of permissions do they need? So on and so forth. Once we have the information that we need for generating a token, we have a number of different ways to get the token from the Respoke APIs. What I've done here is I've actually just done a HTTP post directly to the REST APIs from Respoke, just because if you're doing just one thing, I found that that's the simplest way to do it. It's just to go hit the RESTful API. If you want a richer server-side interaction with Respoke, we do have a number of server-side libraries. I'll go through those in a little bit. But we do have, for Node, it's the Node Respoke admin library that you can use. It's on NPM install Node Respoke admin. And it gives you sort of a JavaScript API for interacting with Respoke and with, for doing things like generating tokens, but also making connections, sending messages, receiving messages, handling webhooks, those sorts of things. So when you connect, when you issue the request for your token, v1 tokens is the route. The header that's important is the app secret header. This is the UID that I showed you a little while ago from your application screen. And the body is the application ID for the application that you're requesting the ID for, the endpoint ID. Once again, this is what is defined by your application that you want to use to identify what this, who is this user who's connecting. Then you specify the role name. This is the name of the user that will be, or the name of the permissions object. So I will show you this on permissions. I created a single role called all. This is usually what I do early in development when I'm not as worried about permissions, is I'll create a role named all, and I will just turn on everything. I will let it use turn. I will let it list groups. For the global group permissions, I will just turn on everything. As you get into refining your application, then you can say, okay, for the engineering group, I can get the subscribers, publish, and subscribe, those sorts of things. So create your own roles sort of per group as you need to. There we go. That's all we need from that. Also, there's the TTL. Because this is a demo, I've set it fairly short, about an hour. And that's it. When we get the token, some error handling, and then really all we need to do is send the response back to the client. And for me, all I need to do is send the token, send the endpoint ID, and because I'm running this demo locally, I also need to tell it which URL to access. In general, you don't have to worry about the base URL because you're going to be hitting the production Respoke services and not internal development services on your laptop. And really, that is it in terms of the server-side application. Into presentation. Okay. Now for the client. As I said, this is an Angular application. I've structured things so that I can just edit the JavaScript file and the HTML will figure it out and just sort of things will come live as I walk through this application. You guys seen live coding a lot? And it's always really, really boring as you see people hunt and peck. So I'm going to try to not do that. I've got things prepared. I will do a walkthrough of the code. You guys stop me as things, if I go too fast or things are a little confusing. So let's see. So here we are getting started. The way this application is going to start is just respoke.createClient. As I said, the Respoke APIs handle multiple connections, and so if you need multiple connections to the Respoke services, you would create multiple client instances, and each client will have its own connection to Respoke. The first thing that we do is we're going to connect to the Respoke services. This is going to issue an HTTP GET to the route that I just showed you that you implement in your application route. And when this returns, there's some error handling, and then we will take the token that we received from that route, and we will use that to call the client.connect method. This returns a promise or has an asynchronous callback on success. Once we're connected, then we can set our presence to available and say, okay, we are connected, we are available, we are here on the Respoke APIs. Let's see. Right here. So this is what the application looks like. From this session, we were assigned an endpoint ID of Juan. Just that was the name that was randomly chosen. We are connected. Here is the connection ID, AEE63 whatever. One of the things that you will see is that as you refresh the browser, it establishes a new connection, and you will get a new connection ID. And so the connection identifies that connection, and you get a new connection ID every time you reconnect. This is another important thing with Respoke, and actually any WebRTC application, is that it really works best with a single page application where you're going to have a single HTML page that houses your application and updates dynamically. If you have a traditional web application where you're changing screens as you click through links, then you're going to have problems because the WebSocket that we have connecting to Respoke is going to disconnect. The media sessions that you have that's going to be playing audio, listening to your mic, whatever, it's going to disconnect. If you do have a traditional web application, it's probably best to have a pop-up frame where Respoke is going to live sort of in parallel to navigating through your web application so that site navigation doesn't interfere with the Respoke connection, or your media connection, or any of the other things that WebRTC is going to use. So that's fairly straightforward. The next thing I'd like to demonstrate is peer-to-peer messaging. What we're going to do is we're going to have an inbox, which is just an array of the messages that we've received. And as I've said, I've coded up the HTML so that as things populate into the inbox, it'll be displayed on the screen. Whenever we receive a message, I'm just going to do some checking, push the message directly into the inbox, limit that to about 5 because I found that it gets confusing when there's more than that, and then a handy little thing to get Angular to update. What I've done in this application, there's a number of ways of doing this, but I put a global event emitter or a global event listener on the client itself for any messages. So any messages that are received, whether these are messages from other endpoints that are peer-to-peer or messages that are group messages, they will hit this callback handler. And all I do is I'm going to parse the timestamps so it'll get displayed in a friendly way on the HTML page. I'm going to call my receive message function so that this message will be dropped into the inbox, and then I'm going to update my state to say I got a client message. And then for sending a message, here I've got my message object. The HTML is already wired up so that whenever I update my endpoint ID and update the message field, those will be filled in here. And then I also have a send message function that's linked to a button on the HTML screen. Whenever I need to send a message, I'm going to copy off the message so that things don't interfere with each other. I'm going to client.sendMessage is going to specify the endpoint ID, the message that I want to send. And I've got another little help. This is a helper that I'm using to sort of indicate to the web application as to when I'm ready to be able to send messages so that we can only send messages when we're connected. So here, there we go. And I'm going to, sorry, wrong button. That's for later. Okay, so we have one is connected to the Respoke services. He's connected. He has his endpoint ID. Let's create another connection. Here we have Marion. Marion is also connected to the Respoke services. If one wants to send a message, you can see this was received on the inbox. There's the timestamp when it was received. It was from Juan to Marion, and he got the message. Similarly, fairly straightforward. As I said earlier, the other thing you might want to do is send messages to a specific connection ID. This is the connection ID that you would specify in the parameters of your send message call. Okay, so now Marion has two different connections. We'll copy off this connection ID. There. Okay, so the Marion with the connection ID that I specified received the message. The other Marion did not. If I do not specify the connection ID, that message is received by all of the other endpoints that share that endpoint ID. Okay, questions? All right. Now it's going to become a little more fun. Oh, yeah.
Do you have message queuing? Something stored on the server if the connection is offline?
Sort of. For our mobile SDKs, we do, whenever a connection is offline and you have a message that's flagged for push notifications, we will store that on our servers so that it'll receive the message when the endpoint connects again. But that's the extent of message queuing that we have so far. And message history is on the roadmap. So where on the roadmap, we can't tell you, but it is there.
queuing like on like a non-mobile device? Like, so let's say like you send a message to a connection and then like all of a sudden they disconnect before they receive it, then it's just gets lost.
Right, it's best effort delivery. So. Okay, any other questions? All right, good. So now let's talk about group communications. So for this section of code, what we're going to do is we're going to wait for our connection to establish, and then we're going to join a connection. In this case, we're going to join a group named global. I've decided to have a group named global that everyone joins, and that'll give me sort of a global address book of who is it in my application. Excuse me. Whenever we receive a join event, for whenever someone joins our application, I'm going to just sort of fake out a message saying, oh, look, I've received a message. The message is joined from whichever endpoint ID. Event.connection.endpoint ID will tell you the endpoint that joined, to the global group, and that they joined. And similarly, on leave events, I will not do that. I will fake out a message that says that someone left a group. Then I will refresh global members. We'll show that in a minute. When I'm done joining the group, I'm going to go refresh our global members. This refresh global members is a function that you could ignore sort of the queue resolve and the .then stuff. That's some promised trickery I had to do to make sure that things only happened once at a time. But this is the APIs that we have for accessing the members of a group. So every time that my application receives a join or a leave event, or every time my application joins this global group, I'm going to issue a get group call to the client for the global group. I'm going to call get members, and this will asynchronously retrieve all the members of that group. When I get those members in, I've got a global members array that the HTML is wired up to look at for populating an address book, basically. And I will filter out let's see, the join and leave events, as I mentioned earlier, they are per connection. So if you have 3 devices that share the same endpoint ID, you will see that endpoint ID show up 3 different times in the members list for those 3 different connections. And so this little dense piece of code here will take the members list, get the endpoint IDs from that list. It will remove yourself from that list. It will get the unique values from there, so that will remove any of the duplicates. And moving on. Let's see. That was some other cleanup I had to do on disconnects, and then other Angular trickery in order to get things to refresh. And then finally, I'm adding a disconnect method here so that we can see leave events more easily. Let's put that there. Wait for the app to refresh. Okay. So here we've got one. He's connected. We can see that he saw Marion join twice. Here are both Marion connections. And actually from this, you can kind of see what the join order was. One connected first. He was able to see this Marion connect second. And then when this Marion connected third, he was able to, he didn't get any join events. I will create a third connection just for the purposes of demonstration. Oh, this is Pearl. That's a nice name. Pearl was able to connect, and you can see that all of the other members of this global group got the join message saying, hey, Pearl is here now. And now I have way too many windows. So, well, here. And what I've done is I've wired my application into this global address book. So if Pearl wants to send a message to Marion, I've got a drop down now. that I can pull from. And you can see that that was received by both of the Marion connections. At this point, I believe I will get rid of, if we disconnect, fairly straightforward, you can see Pearl left the global group. We received the leave event telling us that this endpoint, or the leave event specifies the connection that left the group. So let's see, moving on. That's groups and group membership. Any questions about that? Yes?
So if you close your browser tab, would that be equivalent to the disconnect?
Mm-hmm.
Okay, I just want to make sure.
Yeah, and so here, Pearl has joined, closed the tab, Pearl has left. So in terms of closing the browser tab, that's a fairly immediate disconnect. If someone were to go on standby or shut their laptop lid, we've seen browsers behave in different ways in terms of how long it takes them to detect, or how long they issue disconnects or what their behavior is. We do have timeouts on the Respoke side so that and keep alive so that if a connection has been idle for some number of seconds, I forget what the timeout is. I think it's less than 30 seconds. If we can't contact a connection for 30 seconds, we'll consider that to be timed out and we'll disconnect from the Respoke end. So, yeah.
Is there a constant ping? You said that you can talk about that.
Yeah. Every few seconds, we'll send a ping from the server to the client, and the client will respond to that ping. And actually, it goes from both sides. If the client goes, however many seconds, I think it's 30 seconds without hearing that ping from the server, it will also say, well, I must have lost connection, and it will issue a disconnect too. So if you've got a client that's roaming and has dropped off the network. We've also seen browsers be really inconsistent as to what their behavior is. I've seen sometimes where I turn off Wi-Fi and it's just everything shuts down immediately. And then there are other times where I turn off Wi-Fi and it's fine, it just sort of hangs out. But it does resolve itself, in less than a minute. I think the timeout's around 30 seconds, so. All right. Okay, so let's talk about group messaging. For this example, I'm going to just statically create two groups. I'm going to name them Engineering and Break Room, which are the two most important groups in any organization. As an engineer, I would say that. For those groups, once again, I've got some JavaScript promise trickery with this join.then. Don't worry about that. Really all we need to do is client.join and the ID of the group. You saw earlier I had a global client listener for messages. I'm going to reuse that same global client listener so that if group messages are received, I'm going to use that to populate our inbox so I don't have to do more code here. Usually in an application, though, you want to be much more specific in what you're receiving. So the groups themselves have message listeners that you can associate. So you can either do group.onMessage or pass in an onMessage handler here. That callback will be called whenever messages are received specifically for that group, and that allows you to be much more specific in your code and have, instead of, oh, I got a message, well, let me, doing a lot of routing yourself in your application. You can just have a closure right here that knows, oh, here's the group's inbox, let me drop it in there. This is a very simple example, so I did not bother with that. Okay, after we are joined to the groups, I'm going to add a send message function, or I'm going to update the send message function that we already have. If the endpoint ID that we're trying to send to begins with group : I'm going to, does not end, or this is application specific. Let me go back. How does that happen? Oh yeah. So one of the things that I've done is in our in the endpoint listing, we saw the endpoint listing that dynamically changed as members joined and left the global group. I've statically added these two groups to that listing And I've given them a value of group : group name. So that's what we're seeing here is this is application-specific code. You would determine how you send messages specific to your application. Normally what you have is you have a context. You've got this window represents this group, and if I type into this chat box, I know which group I'm sending it to. In this context, we're selecting from a drop-down, where do you want to send the message? If you're not sending it to a group, I'm just going to call the send to endpoint function that we had earlier. If we are sending to a group, I'm going to extract the group ID from the endpoint ID that we had selected earlier, copy the message out like we did before, sending a group message. Here, instead of holding on to the group object like you normally would, I'm just going back to the client saying, give me the group with this group ID. And we will send a message to that group ID. Here is the message that we're trying to send. And when that's done, we will set state. There we go. Wait for the app to refresh. Okay, so now we have some broadcast groups. Let's see, I do not need the second Marion. I will need to bring Pearl back. Okay, so here, now we've got engineering and break room as options of where we want to send our messages. So once again, you can send a message specifically to an endpoint. You can see Pearl receives that message. Juan does not. If I were to send a message to the engineering group, this message is delivered to all the members of that engineering group. And you can tell when you receive the message in terms of its addressing that it was from Juan and it was sent to engineering, as opposed to from Juan and sent to you individually. So, any questions about that? All right. Now for the exciting part, video calls. Here, to start off with, this is some Angular infrastructure for turning elements on and off, as far as like when we show the video elements, we'll show them when we're on a call and that call has a video stream. When we show the call button is when we've selected another endpoint. And then for starting a video call on the client, as I said earlier, you start video call. It's fairly straightforward. You give it the endpoint ID of the endpoint that you're trying to call. These are peer-to-peer calls. Then there are a number of options for dealing with this. You can read up on these in the docs. I've opted to go for the simple route. I already have video elements in my HTML that are ready and waiting to be plugged into these remote streams. And so for this, you can pass your video local element, get element.id. I've got my local video element and video remote element, get element.id for that. There's another option where you can receive event callbacks for the different media streams, and then you can update the HTML with these brand new elements instead of reusing elements that are already in your HTML. The only thing I will say is that I have seen, using this method, I have actually, in the course of building this demo, I've seen browser bugs where sometimes reusing an element, you run into a situation where you get black video. I don't know, it's kind of weird. So you may want to go with the alternate method of having event listeners and updating HTML with brand new elements instead of reusing the elements that are already there. Let's see, so this is the origination side. This is the person who is starting the video call. It's very straightforward. Start video call, the endpoint ID of where you want to reach. On the answer side, there is a call event callback that happens whenever there is a new call. On this call, I'm going to attach an event listener for the hang up event so that we know, okay, this is when the call is hung up. This call, the call event, it gets emitted on both origination and answer. If you're both placing the call or if you're receiving the call. So if we're the one who is placing this call, we're going to stop further handling here. At this point, when we're receiving a call, This is where you would have some more logic on your side, typically of popping up a dialog that says, do you want to answer the call? If it's a video call, you would have what we call a check your hair mode, where in the answer screen, you'll also show like a little preview of the local media, excuse me, where they can make sure that they're not picking their nose or whatever. I mean, you just want to be able to make sure that things are not too embarrassing whenever you click answer on that call. Because this is a demo, I'm just going to go straight into call.answer. This is once you have that call object, once you've confirmed, hey, everything's ready, I'm ready to answer this call on the answer side, call.answer. Once again, on the answer side, we have our local and remote video elements. Once again, they are also event callbacks that give you new elements you can update your HTML with. I went with a simpler method here. The other thing I've done is, and this will be interesting, because everything is local, calling yourself is fairly non-dramatic. So the constraints I've put on the answer side is that I want a fake device. This is not supported in Chrome. It is only supported in Firefox. In Chrome, there's actually like a startup flag you can pass in when you start Chrome to wire up fake audio and video devices instead of your webcam. And those are great for testing. If you want to say, okay, is it my webcam or is it something else? Is it the network or things like that? You can start Chrome with the use fake device for media stream, or you can pass the fake:true constraint on Firefox. Either one of those methods, it will give you a media stream. It will always give you a media stream, even on a headless server. And it will give you, actually I'll show you in a minute. So there we will be on call. So here, it's going to be more fun. I'm going to bring in, Okay, so we have a Firefox endpoint now, because Firefox is going to be give us a test stream. Get that over here. Juan is going to initiate the call. He is going to call Mina. We place the call. There's the very typical browser permissions. Do you want to access the camera and microphone? Once again, these are browser specific, and it's also browser specific in terms of when it prompts you. For the most part, over insecure origins, whenever it's just HTTP, it will prompt you every time you want to access the camera and microphone. In Chrome, the first time you access the camera and microphone over to an HTTPS origin, it will remember that setting and will not ask you again. Firefox tends to be a bit more annoying and ask you a lot until you go in, and on the site you can say, never ask me again. But both Chrome and Firefox, I haven't tested other browsers for over HTTP. They're fairly consistent in that they always ask you for permission before they grab your camera and microphone. So for one, we will allow, and then we should see that. Oh, unless things break. Things gonna break. Oh, you're right. Yeah, I spoke too long. Okay. Let me just refresh on this. And this is Mina. Call, allow. Of course not. Oh well. There we go. Chrome works. So, and the sweet sound of feedback. Because everything is local. And there. Hi, everybody. So, and you can see that, for this in the HTML, I've got the remote media stream, a little tiny preview of the local media stream, hang up button. So fairly straightforward for that. Let's see. So the final piece of code that I have is actually integration with Chan Respoke. This was, let's see. And can't see that at all. I'll try something different. Sorry, just one moment. And there. Okay. So Chan Respoke within Asterisk. So Chan Respoke is it's fairly straightforward to install. Their installation instructions are in the README. When you do install it, you'll get a sample respoke.conf file, and in general, most of it you don't need to mess with. We have this is our example app section. This is a section where you would program in your app secret. And then I'm using Asterisk configuration templates so that I don't have to do a lot of repeated configuration. But all of my endpoints are going to have the same configuration. The type is going to be endpoint. You specify the transport and app that was defined above. And the transport, by the way, the transport is always going to be a socket IO transport. I've specified the URI and the URI API here because I'm running things locally. You would just not specify that. It defaults to using our production servers. The app is where you specify your app secret. Then on the endpoint, I'm going to use the transport, the example transport, the example app. I'm going to enable turn. The context when I drop into the dial plan is going to be from Respoke. Very typical Asterisk codec configuration stuff. DTLS, this is an important thing to read carefully on the Chan Respoke README, is that we have scripts in Chan Respoke for generating self-signed certificate and private key for use with DTLS, and that works great with all the browsers. One thing that we found out actually fairly recently is that the default scripts for generating DTLS keys within Asterisk actually generate such a big certificate, and because it generates an entire certificate chain, that in trying to make like very long distance connections, you're much more likely to have some point in the path that has a lower MTU that's just going to kill your negotiation. It was a bizarre thing. So be sure to read the README in terms of generating the certificate you need for DTLS. And then that's it. We're going to have a couple of endpoints. I have an anonymous endpoint that does not register itself, but we do have an endpoint named Asterisk that uses this template configuration. You would do a similar sort of thing that as you have multiple endpoints on the Asterisk side that you want to be able to send calls toward, you would create more endpoint entries in your respoke.conf file. Similarly, also in terms of keeping this a very simple example for the demo, I'm going to answer the call and then I'm just going to play music on hold. And once again, this is Asterisk. This is typical dial plan. You can do whatever you need to. And actually, what the more interesting things I've heard about is people taking the call and sending it into stasis so that you can integrate with ARI. And so you can have your server-side application integrating with both Respoke and with ARI, and you can actually bring both sides together within your application. You can see, oh, here's some Asterisk stuff that's going on, and I can identify calls and channels and set channel variables and things like that from an ARI perspective, in addition to working on the WebRTC side in terms of the Respoke endpoints coming and going and that sort of thing. So this is fairly straightforward. I actually already have Asterisk running. And so let's enable. So for this, I actually finished this morning, so there's not a lot here. In order to start an audio call to Asterisk, it's start audio call, just like you would any other web endpoint. The endpoint ID is Asterisk, and the only reason why it is Asterisk is because I named my endpoint Asterisk here. You can name them whatever else. I think we have basic, mixed down, whatever, in our example configurations. So here, we will allow this connection. And actually, it's going to take a few seconds. We've recently identified a bug in Chrome in terms of integration with endpoints that do not support trickle ice, and that includes Asterisk. It takes a few seconds for it to actually decide that it's finished sending ice candidates, and it's only in a, there we go. See, it takes a few seconds there, but it's only in certain network configurations, and it gets worse under some network conditions than others. For most, and it really comes down to having lots of network interfaces that don't reach out to the internet. So developers are going to run into this a lot if you're running VirtualBox, if you're running Parallels, because all of those VM technologies are going to create, little networks that are just there, and Chrome is basically waiting on stun resolution on these networks that are never going to resolve. It was a bug, they fixed it, it broke again, and it's apparently a battle in Chrome. We're looking at what we can do on the Respoke side to improve that time so it's not such a timeout when you hit those network configurations. For the most part, non-developers, your typical users of applications, are never going to see this. Chrome can figure out very quickly, oh, I've got my single network connection, or I've got my 2 network connections. I've resolved stun on both of them, and it can do it quickly and proceed on with the negotiation almost immediately. So, and the fabulous Asterisk music on hold. So that's it. Yes.
I saw in your configuration file that you can stun and enable there. Can you disable that, and would it still work?
So that was turn that was enabled, and yeah, that was turn. The call will still work as long as the ICE negotiation can complete, and from what we've seen, usually a call will work without turn, without stun less often, but without turn, usually a call will work. It really depends upon the network configuration you have and what firewalls are in place, what they have blocked, what they allow through, how the ICE process goes in terms of identifying candidates and nominating them in the ICE selection process.
So isn't this where Respoke is supposed to come in and stuff?
Oh yeah. So if you enable turn, we have things set up so that it should work. If you enable turn, then as a fallback, we will go through a media relay that we as Respoke run, and that's the last resort, is having to use a media relay. What you really want are your media endpoints to be talking directly to one another and not having to go through other servers on the internet. So, and with that, it should work. We have seen still, crazy firewall settings out there, and inevitably someone runs into that, So, but that's a very off-nominal case. Usually, as long as there's a network path, audio is going to flow. So, and I will talk about some audio debugging techniques here in a few minutes, so that if you do hit those situations where audio is not playing, or your video is not playing, or things just generally aren't working, how you debug that and figure out what's going on. It's a good question. Anything else? Yeah.
I was keen to know a little bit more about your architecture in terms of ways how it's called in the United States and the cloud architecture around the world.
Okay, so the question was a little bit more about the Respoke architecture. I think we can follow up with that sort of when I'm done with the slides here. So, because I could probably go on for a while if I get started on that. So, any other questions? All right. So that's it for the coding examples. I hope that was interesting. As I said, the code and the slides are up on GitHub. You can go check that out. And there's a very limited documentation, as in there's zero documentation on that. I'll hopefully have some time to add that in there. There's a lot of other cool stuff that's in Respoke that I really didn't have time or the energy to put into this training session. We do have a number of server-side SDKs. We have .NET, Ruby, Java, Node.js, of course, I talked about that, and PHP. I believe that's the full list. All of our server-side SDKs and our client-side SDKs are open source on github.com/respoke. You can find those. And on our docs site, there's a drop-down for server libraries. You can go to and find more information about that. And we've got detailed information there. We also have detailed information in the READMEs on the individual server SDKs. Let's see, screen sharing is a lot of fun and has been really useful. This does require a browser extension or a plugin, depending upon which browser you're dealing with in order to access screen sharing. Screen sharing, they're still figuring out how to work that into the core WebRTC spec, and there's some disagreement as to what that should look like. But what we do have, actually up on GitHub, we do have example plugins for you to start from in terms of building your own plugin for your application. Endpoint.start screen share will start a screen share with that remote endpoint. It will also do its best to try and detect if the plugin is installed. Is there anything else, Michael? I think that's okay.
I think they've begun working on a newer version of specs for screen sharing.
Yeah.
It'll probably be a year or two, but that should make it so that given some concessions, you won't need a plugin in some sense.
Yeah, so Michael said that it may be like a year or two out before the standards bodies agree on what screen sharing should look like without plugins. So, but in terms of core WebRTC, being able to share your media sessions, audio, video, without having a plugin, being able to do it directly from the browser or from mobile applications has been tremendous. And it's been really good to be able to do that without having to have plugins or worry about plugin versions or that sort of thing. PSTN integration. We have this. You do need to, because of various international billing constraints and things like that, you do need to contact support in order to enable PSTN for your account. But it's fairly straightforward. You start a phone call, you give the number that you want to dial, and you can specify caller ID. The caller ID does need to be caller ID that we do associate with your account. You can't just spoof anybody's caller ID that you want to. So, sorry. Let's see. This was a question from earlier. In terms of push notifications, whenever you send a message, and this is both sending messages, direct messages to an endpoint, or sending group messages, there's a push flag that you can just specify to say, okay, whether push is enabled for this message or not. And if there had been, there's a lot of steps to get it working, which is why it's not a part of my demo. But we do have a docs on docs.respoke.io that'll walk you through both GCM for Android and Apple Push APN for Apple for iOS devices. When your mobile device connects, it can specify whether it is a mobile device or not and what its push token is. When you configure your application, you can specify the credentials that you want to use for push notifications. And once those have been set up, after the mobile device disconnects, that connection will go into a push mode instead of being just disconnected. And any message that has push:"true" will send a mobile push notification to the device. The message will be queued up so that it will be later delivered when the client reconnects. Also, direct messaging. This is an interesting little side corner of the WebRTC spec. My guess is that they said, well, we've got these direct browser-to-browser connections that we're sending voice and video. Why don't we just send raw data over that? So there is a WebRTC spec called a data channel. We have support for that through the Respoke.js APIs. You just specify for a particular endpoint .start direct connection. And this will start, it's a secure connection that's browser to browser that you can send messages to. This would be useful if you've got maybe some enterprise communication constraints. Maybe there's some area of your application like source code synchronization or something like that, where the enterprise has some rule that says the code cannot leave, cannot leave our VPN. It cannot leave our intranet. Well, this allows you to specify an encrypted channel browser to browser so that you can have a direct connection. as we were talking about earlier in terms of making connections work, it may decide that it has to go through turn in order to relay the connection. You can disable that if you need to, so you can say it's either a secure connect, it's either direct connection, browser to browser without turn, or it's not going to work if you're really concerned about that. But it's an interesting thing. For the most part, for most applications, once you have Respoke messaging available to you, you just sort of send and receive messages that way instead of using direct connections. But I can see where if you have an enterprise where you've got some security constraints that are a bit atypical, where you would want to use direct connections for sending media directly from one endpoint to another. It's also useful for things where, maybe like large file transfer or something like that, where you don't want to go through a relay server on the internet. So, questions about direct connections? Cool, we're doing well. Early access, we have audio conferencing. We have video conferencing on the roadmap. Where on the roadmap, we can't reveal, but it is on the roadmap. This is also very straightforward. The audio conferences are just like our messaging groups in that they are ad hoc. You client.join conference and you specify the ID of the conference you wish to join. If you're the first participant in the conference, you'll be there with dead air, not talking to anyone. As other participants join, it's multi-party audio. Today we're in mixed mode. We're looking at different, tuning different things and figuring out, okay, is that the best thing going forward? Do we need to just do forwarding? What have you? But so that is, but that's fairly straightforward. It's a really interesting feature. If you're interested in audio conferencing from web applications, contact us and we'll set you up. Troubleshooting. Here are some gotchas that we run into frequently in terms of building and debugging WebRTC applications even. This is less about Respoke and more generally just WebRTC applications. The biggest thing that you'll find is that there are no audio. You'll make your call, everything looks like it should be fine, and you don't hear anything. Maybe you'll even see the video, but you don't hear anything. First thing, I know it's kind of silly, but check your volume settings. Also, in the browser, you can check which input device that you're using. On Chrome or on Firefox, you'll see a microphone show up on the address bar. You can click that, and you'll get more specifics as far as which input and output devices you're using. A really helpful debugging technique when you're having these sorts of audio problems, is to actually just add a very simple sound file to your application, even if it's just something like ring.wave that you play before you place a call or when a call comes in. And that just helps you have a little assurance that, okay, at least the media, the audio path from my browser tab to the speakers is working, because it's amazing how many times that's a problem, especially on Windows, because for some reason on Windows, you can control the media, or you control the volume down to a per application level. We spent a long time trying to figure this one out on a Windows box, that for some reason their Chrome tab had volume turned all the way down. So they could hear sound from everything else, but this one Chrome tab, no. And it was the one that they really wanted to hear audio from. So that's an important thing to check too, is that it could be anywhere. And then that's where having a simple audio file that you play is really helpful. If you're using Respoke and you're having media issues there, and Respoke can be a little finicky because it is Asterisk, and you can do so much more with it, and it's so much more complicated. You're probably not just doing music on hold like I was. You're dialing SIP endpoints. You've got your own, SIP trunk that you're trying to dial, or you're trying to ring phones, or you're trying to water plants. I don't know. If you go to the Asterisk wiki, wiki.asterisk.org, you can search for collecting debug information. You can find the page there. That debug information is really helpful in terms of trying to figure out why you're not getting audio or media connection or whatever from an Asterisk perspective. Let's see. Content security policy. The other thing that we found is as Chrome evolves over time and they add more security features over time, or they tighten things down, that you'll have your application work with a particular version of Chrome, and then there's some tweak where it won't work with the next one. The more recent ones we've had come up is, the first is content security policy. If you've never heard of content security policy, then this probably does not apply to you. But there are some sites where they've decided to enable content security policy, because it's security, it's got to be better, right? In Chrome 44 and earlier, it by default included blob URLs in the default content security policy. They changed that in Chrome 45. And so we had a customer with an application that worked fine until Chrome 45, and then it stopped working. If you are using CSP, then there is a media source line you can add. You just add blob to your media source line, and then that will allow blob URLs. So the blob URLs are the ones that are created from the WebRTC connections for media endpoints. And like I said, if you've never heard of CSP, then you're probably not using it, and this isn't an issue. You can look for a content security policy header in your HTML headers on your when your page loads, and you'll see a header. It's going to look a lot like this, where it defines content security policy for all sorts of things, and look for a media source line. And if it's missing, then it'll default to self and that sort of thing. So adding that media source line is how you would work around that. It's fairly straightforward. The other thing, I don't believe this is out yet in stable versions. It may be in Canary or beta. Chrome is deprecating the use of get user media over what they call insecure origins. Fortunately for developers, they're including localhost within the definition of insecure origins. So if you're running your application on localhost, it'll be fine. If you're running application over HTTPS, it'll also be fine. But if you want to do audio or video, and you try to use that like on a JS bin or something like that, where it's over plain HTTP and it's not over HTTPS, then the browser is going to reject your request to get user media, to grab the mic, to grab the camera. So that is coming in. It's coming soon in Chrome, and I believe it's on the roadmap in Firefox too.
And I believe it's also correct you can't use self-signed service either.
That is true. You need to, over HTTPS, it needs to be like a green lock icon. So normally what people will do is they'll use a self-signed cert and just tolerate the fact that they get a red lock icon. That's not, Chrome will not consider that a secure origin. You need to have, an actual cert. So fortunately, I forget the name, but there's movements now for providing, more widely providing cheap or free HTTPS certificates to people. So the expense of getting a real certificate for your website is a lot less than it used to be. And, and really, it's reaching the point now to where I think most things on the web really need to be over HTTPS anyways, just because it is the web. And if you have an application where you're going to grab some user's camera or you're going to get their microphone, you probably owe it to them to be over HTTPS just so you can avoid things like man-in-the-middle attacks. Someone hijacking your application midstream because it wasn't encrypted, those sorts of things. So, let's see. Okay, last resort when it comes to debugging audio and video problems is that these get into what we were talking about earlier, the really, really weird networking situations where just there is no media path. There is, it's like the firewall's breaking everything, nothing's working, that sort of thing. You can, both Firefox and Chrome support WebRTC debug information. It's very different from both of them. Chrome will give you WebRTC internals. Firefox is about WebRTC. If you're not familiar with that WebRTC, it's a lot of information and it's a lot to make sense of. Fortunately, community.respoke.io, we are very glad to help you out. If you're having problems, just post what your problems are. More than likely, if it's not an obvious thing or we can't resolve it quickly, we'll ask you to go to the WebRTC debugging information and to collect some debug dumps from there to post to either to post on the community forum or to send to our support email address if it needs to be confidential. Or if you're like me and really like getting into the gritty details of things, you can just open that up and see what's happening. And it's also cool to just watch those tabs when you're doing other things like Google Hangouts and see what they're doing with WebRTC. So, and other voice and video. Actually, and that is the end of my prepared presentation. Look at that, an hour and a half. So we had a question earlier about the Respoke architecture. How much should I get into that? Do you know?
I think, and after that question.
Yeah.
So I think I heard you also mention like geographic distribution and areas and all that stuff. So
I'll talk about it. I've got the mic. So in terms of that, we do leverage AWS. So all of our services run in AWS, and we leverage their region facilities as well. We have media relay servers in US East, US West, EU Central, EU West. Yeah, okay. So we have media relay servers in those locations. And so for Europe and US, media relay should work out fairly well. When it needs to fall back to that last resort. Like we've said, for most WebRTC connections, stun and other negotiations tend to work out fairly well, and you tend to not have to fall back to turn, so that's good. In terms of our core messaging and other services, those tend to all be in US East. So, and we have, there are people who are using Respoke services from South Africa, and at least latency is not a complaint that they have any more than they have with any other website. So let's see. Is that in? Okay, yeah. So, okay, great. Yeah, you should have a lot of good luck with using Respoke. Okay. The question was, do we have plans for standing up media relay servers in Asia and Singapore? We don't have any plans, but like you said, it's AWS, so it's fairly straightforward to do so. If you're interested in that, you can contact Michael, who's over here. He's in charge of making decisions, or you can contact our support site, support@respoke.io, and we'll be glad to talk with you about doing things like that. Yes?
You talked about video conferencing. Is there anything on the Respoke site where you're going into video broadcasting?
The technology is fairly, it's fairly the same technology, in terms of, it's still the same video mixer. It's just, and the way we've discussed designing the APIs is so that, you would have one connection who would connect and say, I'm presenting video, but I'm not receiving anything. I'm just going to be the presenter. And then all the other connections can connect specifying, I'm receiving video, but I'm not presenting anything. So we've talked about that in terms of our design. The trick, especially with video broadcasting, is that typically when you're talking about that, you're talking about, thousands of connections or things like that. And so that's, those are the further things that we need to think about in our designs and our implementation before we get to that point.
Thinking about video broadcasting, but having secure data channels that cannot actually play or even still talk,
Mm-hmm.
or even still establish peer-to-peer communications.
Mm-hmm. Mm-hmm. Yeah, and so for that, Respoke would be great once we get to the video conferencing, once we add video conferencing support, because we do have data channel support, so you should be able to handle that nicely. All right, any other questions? Yes?
Just a couple of questions on kind of the reliability. It goes from the stun and then it falls back to the media relay. So
Mm-hmm.
kind of maybe percentage-wise or something, what are you seeing in terms of like how many connections just work, how many have to fall back to the relay, and then how many don't work at all? Like, have you any kind of rough numbers on that?
I do not have numbers on that. Michael?
Or even in general, like,
All right, so
do most of the calls work at some point, or do you have any breakdown of it?
All right, sorry, for the microphone, the question is, what is the reliability of the media connections? How often does direct connections work or stun connections work? And how often do you have to fall back to a media relay server? So.
Yeah, so I'll try to talk loud and then you can repeat after the microphone. So roughly 15% or so of the calls with web-to-web earlier on were required turn. On the mobile side, I don't know the numbers off the top of my head, but it's definitely larger on mobile than it is on web-to-web. And in terms of connections that absolutely aren't able to be established, we have seen it, but it's super rare. So I don't have a good number to give super rare actually is.
Okay.
Turn is the media relay server, right?
Correct.
Okay, yeah, so to repeat Michael's answer, what we've seen what we've seen earlier is about 15% of calls required a media relay server. In terms of calls that just were unable to connect all, we have seen it, but in terms of percentages, it's been insignificant. It's just been in really obscure network situations where you've had a very draconian firewall that just did not allow much of anything through. Yeah.
And then one more, how about the browser support? You talked a little bit about how that's come on. I know that was early on.
Okay, yeah, so the question was about browser support. So obviously, I've talked a lot about Firefox and Chrome. Those are the primary browsers that we test with, and that those work with everything. In terms of mobile devices, mobile Chrome in fairly recent Androids has WebRTC support, so you should be able to see audio and video work there. I'm trying to think, Internet Explorer is basically a no-go. Microsoft Edge, the developer preview now has ORTC support, which is not WebRTC, but it's similar enough. And so that is something, once again, is on our roadmap in an undisclosed location. So in terms of Internet Explorer, we have looked at, there are plugins for Internet Explorer and Safari that we've looked at but have had mixed results with, so there's nothing that we're endorsing yet as far as this is how you would definitely work with Safari or this is how you definitely work with Internet Explorer. And then in terms of Safari so far is a no-go. They have not, I don't even think they've implemented WebSockets, right?
So you might want to touch on WebKit or NWJS.
Oh yeah, actually, so that's a great point. In terms of sort of sidestepping these browser requirements, what we've had a lot of good luck with is people using either Node WebKit or NWJS. So you can build, basically it's a really thin Node application that can just load your web page directly in it within Chrome. And so it's a client application that they would have to download and install. But with Node WebKit, it's fairly straightforward to build a Windows app, a Mac OS app, and a Linux app that they can just run as a native application. And it's basically Chrome embedded in your rich application. We've had a lot of luck doing that. And if you enter situations where, oh, the only browser we allow is Internet Explorer 6. Okay, how about this app? Sure, that'll be fine. All right, I just won't mention that there's a browser in here. So, and I do believe if you go to the Respoke docs site, I forget exactly where it is, but we do have a link there that gives more detailed information on supported platforms. All right, great. Any other questions? All right, great. Well, I am really glad I did not have to talk for a solid 3 hours. Thank you very much for your time. I believe that is everything. Michael and I will be around for a little while if you have any other questions. Enjoy AstriCon. Thanks, everybody.